Welcome, pre-calculus class, to the best hour of your day today, I'm sure. Pre-calculus class, Thursday the 17th. Hope you guys are doing well. And you might be an hour. It's not. I'm going to try to go as fast as I can, but we do have a lot of notes to take today. Excuse me, sorry. A little bit of problem with my throat today, so bear with me. But like I always do, I try to teach quickly and be respectful to your time, so let's go ahead and get started right away. Again, I can tell I've got a little bit of congestion here, so just be with me as I will probably clear my throat a lot and also drink some water while I'm doing this video. Okay, announcements. There will be a test on Monday. You should know that by now. If you cannot make it to my house on Monday, be sure and let me know by Sunday. Please just be respectful and let me know. Integrity. Oh, by the way, so you'll have a review sheet tomorrow. I'll give that to you today when the video is over, but I won't have the help video out until tomorrow. But test on Monday, integrity sheet. Stay on top of those. Make sure you're doing your homework every day. Do your videos every day. It's just like going to school, guys, okay? You can't get behind. Fall break, woohoo, fall break. That'll be starting on Tuesday. So after you take that test on Monday at my house, you will not have class Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday, or Monday. And the first class back will be Tuesday. What would that date be? Tuesday, today's the 16th, right? So yesterday was the 15th, today's the 17th, excuse me. So 2 days ago was the 15th. So I would think that's Tuesday the 29th, I believe. I believe that's right, but first day to log back on and watch the video. Okay, moving on. We have a lot to do, so let's get started. We learned yesterday that the expression inverse cosecant, that's how you say this, inverse cosecant of 2.634 is the same thing as cosecant of an angle equals 2.634. In other words, whenever you see an expression written like this, it just means you're looking for an angle. That's it. You're looking for an angle. So when you solve this right here, you're really solving this, so you're solving for an angle, and we learned that yesterday. Today we are going to start combining inverse trig expressions, like we looked at yesterday, with regular trig expressions that we've had in the past. All right? These types of problems are not horribly hard, but they can be somewhat difficult. So please pay careful attention. Please take some great notes and call me or email me if you have any questions. Okay, inverse trig functions is your heading. Please write that down. Excuse me for a second. Inverse trig functions, the lesson number is 6.4, and the date today is the 17th, 10/17/13, okay? Inverse trig functions, lesson 6.4, which is the same heading as yesterday, but we're going to go a little deeper today, all right? So without any hesitation, I would love to give you step 1, step 2, step 3, step 4, like I did earlier this year with some of the review math. But with these types of problems, you really can't do that, okay? So here we go. I would like us to start taking a look at a combination of problems that have regular trig functions with inverse trig functions, okay? So let's go ahead and take this step by step, and hopefully this will make sense to you. The first thing you do is you start inside the parentheses. Do you see that right here? Start inside the parentheses, and we rewrite this the way we learned yesterday. Inverse cosine of square root of 3 over 2 is the same thing as the cosine of x equals square root of 3 over 2. All right? So there we go. Now, remember yesterday we had that chart that I gave you listing out the special angles and all of the trig functions of those special angles. Well, here is that chart again. Put it right there, off to the side, and there we go. Now, let's go ahead and take a look here. I will get rid of this in just a second when we have some room. So what I did is I rewrote the inside right here, okay? Inverse cosine, square root of 3 over 2 is written like this. Now, what angle would I put here? What angle, when I take the cosine of it, gives me square root of 3 over 2? Well, right here. Cosine of 30 is square root of 3 over 2. Okay, so with that in mind, I'm going to very quickly, did not mean to do that. Well, that's okay if I do that because we're going to put it back up again later anyway. So let's go ahead and quickly get rid of this. There we go. And there we go. Now, so what you just saw is that the angle right here is 30. Cosine of 30 equals square root of 3 over 2. So here's what I have now. Remember, anytime you solve an inverse function, you're getting out an angle. So the angle, the answer to this entire function right here was 30 degrees, right? Sure it was. We just saw that. And so now, what is the cosine of 30? Well, pull your chart back up again, you'll see the cosine of 30 is square root of 3 over 2. And there we go. We really went in circles. Do you not see what we did here? Watch this carefully. We said, what angle, when you take the cosine of it, gives you square root of 3 over 2? And we got 30. Then we said, what's the cosine of 30? Well, it's square root of 3 over 2, like we just learned right here. So, either way, you can kind of look at that. They don't always work out that simply, but still, the main idea is this. You take your inverse trig function, and you rewrite it as an equation. Then you solve that equation, and of course, whenever you solve an inverse trig expression, you're getting out an angle or a degree measurement or a radian measurement. And then we took the cosine of 30, and if you'll look at your chart, you'll see it's the square root of 3 over 2. Pretty cool. Let's try another one. Okay, now here we go. First of all, we start inside the parentheses. So we rewrite our inverse function as an equation. So sine of x equals 1.8. Now that's not, if you'll look at your table here, you'll find nowhere 1.8. Nowhere. Okay? So the only way we can solve this is with a calculator. But watch what happens. Go ahead and try to find the angle. Remember, you're looking for an angle. So whenever you're looking for an angle, you hit sine, second sine, and up pops this on your screen. And then you type in 1.8. And when you do that, guess what you're going to get? Depending on what type of calculator you have, you're going to get error, or cannot be defined, or does not work, or something. In other words, there is no angle that exists. There is no angle that exists that when you take the sine of it, you get 1.8. Can't be done. So if there's no angle here, then there's really no angle that you can take the sine of. If there's no angle here, then there's no angle we can take the sine of, so the answer is just no solution, or cannot be solved, or does not exist, or undefined, or however you want to say it. But the answer is no solution. Let's go over this again so you're not confused, okay? The first thing I did is I took my inverse trig function here, and I wrote it as an equation. Then I typed it in my calculator, because this 1.8 is nowhere on my chart of exact number answers. So I typed it in my calculator, and I got out undefined. Doesn't work. So there is no answer to this. It cannot be done. And that happens sometimes. All right, let's try another one. All right, here we go. Now we start on the inside. Here's my tangent. I'm going to go ahead and put a parentheses. Now, inverse tangent of negative 4.2. I'm going to rewrite my inverse tangent as an equation. So tangent x equals negative 4.2. Okay? Now, students, if you'll take your calculators, and if you will type into your calculators, we, of course, are trying to find the tangent, or what angle, excuse me, the tangent of some angle that equals negative 4.2. I have taught you in the past, whenever you're looking for an angle like we are here, you hit second tangent. So it pops tangent negative 1 with the parentheses, then type in negative 4.2. All right, now, if you do that correctly, make sure you're in the degree mode. Or you could be in the radian mode for all I care, but just so you match what I'm putting up here, I'm going to get out degrees. I'm getting out negative 76. So here's what I get out. I'm getting out negative 76.607 degrees. Okay? So I took all of this here and simplified all that down into this angle right here. And now, bring down my tangent, and I simply take the tangent of that angle. So with your calculator, take the tangent of that angle, and you will get negative 4.2. The exact same thing you started with up here, negative 4.2. Okay? So I hope you're seeing a little bit of a pattern here. I mean, it's not always going to work like that, so be careful just making that assumption. But think about what you're doing. You're saying to yourself, what angle, when I take the tangent of it, gives me negative 4.2? And then when you get that angle, you take the tangent of that angle, so you're naturally going to get negative 4.2. It really does make sense. But if you're not seeing that, that's okay. Just follow these steps, just like 2 problems ago. Just take your inverse cosine, write it as an equation, find the angle, put the angle right here, bring down the outside, take the cosine of that angle, and you have your answer. Same thing here. Rewrite your tangent as an equation, find x, which was 76 degrees, and then bring this down and take the tangent of 76, and you'll get the right answer. So either way is fine. All right, now let's try another one here. Let's try the, now it's a little backwards. Did you notice in the other 3 problems, all of the inverse functions were on the inside of the parentheses, inside of the parentheses, inside of the parentheses, and now we're looking at one where the inverse tangent is on the outside, and that's okay. We still start on the inside and we go from there, all right? I think it's always helpful when we use degrees because we're so used to degrees. Now you don't have to do that, but I'm going to go ahead and put tangent of 30 degrees because pi over 6 is 30 degrees. And then next, I'm going to put my table up here, and I'm going to see what is the tangent of 30 degrees. Let's see, tangent of 30 degrees. Here's tangent, right here. Tangent of 30 degrees is, there it is, square root of 3 over 3. So tangent of 30 degrees is square root of 3 over 3. So I'm going to go ahead and put square root of 3 over 3. Do you see that okay? So tangent of 30 is square root of 3 over 3. Then bring down your tangent to the negative 1. All right, let's finish it right up here. So inverse tangent of this means to rewrite it like it's an equation. So tangent of some angle equals square root of 3 over 3. Now think about that, please, students. Think about it. Did we not just say the tangent of 30 is square root of 3 over 3? So now we're saying what angle, when you take the tangent of it, gives you square root of 3 over 3. Wouldn't it be 30 degrees? Well, let's see. Tangent of what angle gives me square root of 3 over 3? Well, let's see. Tangent, let's see, here's tangent. Oh, here it is, right here. Here's square root of 3 over 3, and that would be tangent of 30. So tangent of 30 gives me square root of 3 over 3. So what angle, when I take the tangent of it, gives me square root of 3 over 3? 30 degrees. And if I asked you to write it in radians also, then it would be pi over 6. Pi over 6. All right, let's try the next one. All right. Inverse sine of sine of 3 pi over 4. Now again, for me, I'm going to start off by converting my radians to degrees. It's very helpful. So let's see, what would that be? 180, 35 times 5, 4, 45, 135 degrees. So there we go. All right. So I want to know what the sine of 135 degrees is. Now, believe it or not, students, that can be one of my special triangles. It can? Yeah, watch. 135 degrees. Watch. I go 135 degrees and I stop right here. Draw my terminal side. Now, if I went 135 degrees, what's my reference angle right here? 45 degrees. Because if I would have gone all the way around, that's 180 degrees right there. And I stopped at 135, so 45 more gives me 180. So my reference angle for the sine of 135, the reference angle for 135 is 45. We've done this before. And what are your signs over here? Positive, negative, negative. So guess what? You can definitely, instead of taking the sine of 135, you're welcome to take the sine of 45 as long as you remember that sine is positive in this quadrant. We've learned that before, so hopefully you're staying up on your math, okay? So the sine of 135 is the exact same thing as the sine of 45 degrees. And now let's go ahead and take a look at what the sine of 45 degrees is. All right, here's sine 45 degrees, square root of 2 over 2. There it is. Sine of 45 is square root of 2 over 2. So the sine of 45 degrees would be square root of 2 over 2. And then bring down your inverse sine. And let's finish it right over here so we have room for our table when we pull it back up in a second. So inverse sine, we can just rewrite that as an equation. Sine of some angle x equals square root of 2 over 2. And now let's take a look at our chart. Let's see. When does sine give me square root of 2 over 2? Here's sine. Here's square root of 2 over 2. So here it is, 45 degrees. So what angle, when I take the sine of it, gives me square root of 2 over 2? 45 degrees. So x equals 45 degrees is my answer. or you're welcome to put pi over 4, which is the same thing as 45 degrees. Either way. All right, let's keep working. Let's go. All right, here's the next one. Sine of inverse tangent of -1. Now let's first of all start off, like I've taught you here, to come inside, and let's start on the inside of the bracket or the parentheses, and let's rewrite our inverse as an equation. So tangent of some angle gives me -1. All right, let's pull up our table and see if we have that anywhere. Does tangent ever give me negative? Here it is, right here. All right, look at this. Tangent of 45 degrees is 1. Now, I know I want a -1. We'll talk about that in a second. But first of all, do you see? Tangent of 45 gives me 1. So we're getting there. We're pretty close. So what angle would give me -1? Remember, we learned yesterday that when you're dealing with inverse tangent, you're dealing with quadrant 1 and quadrant 4. We talked about that yesterday. You got to memorize that. So here, tangent is positive. Down here, tangent's negative. So instead of saying positive 45 degrees, we're going to rotate down this way, and we're going to put negative 45 degrees, and that'll work. So the tangent of negative 45 degrees is -1. If you don't believe me, go ahead and type in your calculator. Go ahead and hit tangent negative 45. Make sure you're in the degree mode. And if you hit tangent negative 45 and hit enter, you are going to get -1. So what angle, when you take the tangent of it, gives you -1? Well, that would be negative 45 degrees. And now bring down your sine. Now let's take the sine of negative 45 degrees. Remember how to do that? Sine of negative 45 degrees. Negative 45 degrees would put us down here in the 4th quadrant. So there we go. Here's negative 45 degrees. And we know sine is negative. The sine sequences go negative, positive, negative. So we know sine is negative. So really, sine of negative 45 is the exact same thing as the sine of 45. Yeah. The sine is negative in this quadrant. So what is the sine of 45 degrees? Let's see. Sine 45 degrees, square root of 2 over 2. There it is, square root of 2 over 2. So sine of negative 45 degrees is square root of 2 over 2. But don't forget, we're in the 4th quadrant, and sine is negative there. So there's your answer, negative square root of 2 over 2. All right, let's try another one. Okay, we start on the inside. So I'm going to write cosine or inverse cosine of, I would definitely convert this over to degrees, sine of 90. Now, pi over 2 is 90. Now, if you'll look on your special triangle angles, there's no 90 anywhere. Okay, so we're going to have to use our calculators. So if you take your calculators and type in the sine of 90, make sure you're in degrees, you will get out 1. The sine of 90 is 1. So bring down your inverse cosine. So inverse cosine of 1, because the sine of 90 is 1. And now we're going to rewrite this as an equation. So inverse cosine of 1 means cosine of angle x equals 1. Now when does cosine equal 1? What angle do you take the cosine of to get 1? Well, let's see. Maybe it's on our chart. Cosine. Here's cosine right here. Right here. I don't see 1 anywhere. So my table's not going to help me, guys. Okay? So now I've got to use my calculator. And I've taught you, whenever you're looking for an angle, you hit second, in this case cosine. So second cosine. And this will pop up with a parentheses. Then type in 1 and hit enter. All right? So second cosine and then type in 1. And when you do that, you will get out 0. So the answer is 0 degrees. Or 0 radians is fine also. Okay? I hope this is making sense. We got a lot of homework to practice, okay? And it's about ready to get a lot more difficult now. So here we go. This is going to be a lot of fun. And yes, I'm being sarcastic. Okay, this isn't too hard until I give these words right here, which you're going to love. Give answer with exact numbers. Oh, you love that, don't you? All right. Because real quick, I'm going to do something real quick. Don't write this down. Just watch, okay? If I didn't tell you to use exact numbers, it's a piece of cake. What? Don't write this down. Just watch. It would be cosine parentheses sine of x equals 3/5. And you would take your handy-dandy calculator, and you were looking for an angle right here, so you would hit second sine of 3/5, and you would get out 36.8699 degrees, and then take the cosine of that, and you get out your answer, and you're done. Piece of cake. soon as I throw those wonderful words at you, and be sure to write this in your notes, give answer with exact numbers, we're going to have to work on this a little bit, okay? So first of all, let's do what I've taught you, and that's to rewrite your inverse trig function here as an equation. So sine of some angle equals 3/5. Do you see that? Now notice that 3/5 is positive, okay? So because it's positive, we know we're going to be dealing with the first quadrant. Remember, whenever it's an inverse sine, that means we're either in the first quadrant or the fourth quadrant, nowhere else, okay? So we know it's a positive 3/5 right here, so we know we're going to be in the first quadrant. So I'm going to go ahead and draw my triangle. Now, watch this. I have no idea what this angle is. See this x right here? See this x? I have no idea what it is, and I admit that. I'm going to put x right here. This angle, x, sine of this angle, I have no idea what it is. I don't know what that angle is, but that's okay. Who cares? Really? Yeah, who cares? Sine of x equals what? 3/5. So sine of x equals opposite over hypotenuse, right? Sine of this angle x equals opposite over hypotenuse. So my opposite side is 3. My hypotenuse is 4. And, excuse me, sorry about that, 5. And then using Pythagorean's theorem, you would see that this side down here is 4. So do I know what x is? No, you do not. And so usually when you are solving an inverse sine problem, you want to find the angle. But guess what? I don't care what the angle is. I'm just going to call it x. So what is the answer to this? What is the angle? I don't know. I'm just going to call it x. So now I'm going to take the what? The cosine of x. Students, I don't have to know what the angle is if I have the whole triangle over here, and I've got the whole triangle. So I rewrote my trig function as an equation. Sine of some angle gives me 3/5. I did not know what the angle was, so I drew my triangle in the first quadrant. Why the first quadrant? Because 3/5 is positive. So I drew my triangle in the first quadrant. I still don't know what this angle is, so I admitted I didn't know, and I put an x right here. Okay? And then I went ahead and found all three sides. And then I'm going to call my angle x. So now take the cosine of x. Well, students, the cosine of x would be what? Adjacent over hypotenuse. So the cosine of x would be 4 adjacent over hypotenuse, 5, 4/5. So the answer is the cosine of x is 4/5. You don't have to know what x is when you know all three sides of your triangle. Cosine of x is 4/5. Pretty cool. Okay, let's try another one here using exact numbers again. So we're going to use exact numbers. So the first thing I do is I write down cosine, and then I write tangent of some angle x equals square root of 3 over 4. And I think in my notes, but I wish I had my notes with me, I could have sworn I changed this to a negative just to make it more challenging. Let me look at my notes. Yes, I did. So let me turn back here. Go ahead and squeeze a negative sign in here, would you please? Sorry about that. Let's go ahead and make this negative, this square root of 3 over 4, make this whole fraction a negative right here, okay? So what I'm saying now is tangent of some angle equals negative square root of 3 over 4. Now, I want you to use exact numbers, so we're going to have to draw a triangle over here. Remember, tangent of some angle, inverse tangent, is always restricted to the first and fourth quadrant. And look at this number. It's a negative square root of 3 over 4, so I know I'm down here in the fourth quadrant. All right? Now, I'm going to put my x right here, x degrees. Why? Because I don't know what x is. I have no idea what it is. I could use a calculator and get out some really long decimal answer. I don't want to do that. I'm trying to get exact numbers, so I'm just going to leave it x. And then what is tangent? Tangent of x is opposite over adjacent. So opposite would be square root of 3. Don't worry about the negative sign. We already took care of the negative sign by writing this in the fourth quadrant. So opposite is square root of 3. Adjacent is 4. Now, if you use Pythagorean's theorem on this, and we've done a lot of those, so I'm not going to take time and do that for you, but if you use Pythagorean's theorem, you will get square root of 19 for the hypotenuse. Okay? So, now that I've drawn my triangle, I have no idea what the angle is for this inverse relationship, but I'm going to go ahead and say, okay, the angle is just x. I mean, I don't know what this angle is, so I'm just going to call it x. And by the way, I don't have to know what that angle is as long as I have the triangle. So now the cosine of x equals, well, what is cosine? Adjacent over hypotenuse. So adjacent would be 4. hypotenuse would be square root of 19. We multiply the top and the bottom by the square root of 19 to get rid of this radical down here. So 4 square root of 19 all over 19. Oh, hold it. Hold it. Hold it. I almost made a mistake. Hold on. We're finding the cosine of what angle? X. And what quadrant is X in? Fourth quadrant. So cosine, what is cosine in this quadrant? Okay, we're good. It's positive. Negative, positive, negative, sine, cosine, tangent. So cosine is positive in this quadrant, so we're okay. So cosine of this angle gives me 4 square root of 19 over 19. It is positive. And so there we go. We found the cosine of angle X because we had this triangle right here. Pretty cool. Now, this is going to be a killer. This is going to be interesting, so really, really pay attention, okay? Here, I want you to write your answer, and again, let me get a drink of water. My throat is really bothering me. All right. Here, I want you to write your answer. Write this down, please, in terms of X. Write your answer in terms of X. Now, what that means is you're not going to get out an exact answer with numbers. You will have an X in your answer. This will be fun. All right. All right. Sine, and then parentheses, and then we rewrite our inverse as cotangent of some angle equals, I better use y because we have an x already. Do you see that right here? So do not use x. Normally we do, but not if there's an x already. So cotangent of angle y equals x over 2. Now, look. Cotangent of y equals this. This is what? Positive. Remember, tangent and cotangent restrict themselves to the first and fourth quadrant when it's the inverse of tangent or the inverse of cotangent. So we're in the first quadrant because x over 2 is positive. So we know we're in the first quadrant. So there we go. Now it's angle y. I have no idea what angle y is, but I can still write it right here. Okay? And then cotangent of y would be adjacent over hypotenuse. So here's y. Adjacent would be x. And your hypotenuse would be 2. Now, what I need to do probably is use Pythagorean's theorem for you so you can see how I find this last side over here. Okay? So let's use Pythagorean's theorem to find our last missing side of the triangle right over there. All right, so here we go. Remember, and I'm going to erase this in a second, so write this down. Remember Pythagorean's theorem, L squared plus L squared equals H squared. Well, one leg is x. The other leg I don't know, so I'm just going to leave it L. And my hypotenuse is 2. Now, let's continue on. X squared plus L squared equals 4. Now, aren't you solving for L? We're trying to find this leg, right? So bring the x squared over, and when you bring the x squared over, it'll become a negative x squared, so it's now gone. So we're left with L squared equals 4 minus x squared. Do you see that okay? And now, if I have an L squared, I want to take the square root of it, but if I take the square root of one side, I've got to take the square root of the other side, so I'm left with L equals the square root of 4 minus x squared. Cool. So you found this leg. Remember, I told you you're going to get an answer in terms of x. That means your answer is going to have an x in it, not just numbers. So this leg right here is 4 minus x squared. Now look over that again and back the video up if you need to and watch it again. That's one of the benefits of learning by video. Okay, there's negatives, there's positives. One of the positives, you can go back and listen to it again and again. Watch that over and over until you get it, okay? And you need to do that if you're struggling with that. Okay, so I'm saying to myself, the cotangent of some angle y equals x over 2. I saw x over 2 was positive, so I drew my right triangle in the first quadrant. I then labeled x is the adjacent side, 2 is the hypotenuse. I used Pythagorean's theorem, I found the third side. And now I have no idea what y is, but I know that I have a triangle I can use. So now I simply bring down my sine, and I say I'm going to find the sine of what? Y. Now I don't know what y is, that's okay, sine of y. So here's y. The sine of y would be opposite over hypotenuse. Opposite, oh, I forgot the square root, did I? Sorry about that, guys. Boy, I'm sorry about that. There we go. Isn't that right? Yeah, it was the square root of 4 minus x squared. Very sorry about that. Okay, so the sine of y would be opposite over hypotenuse. So 4 minus x squared all over 2. And we know sine in the first quadrant is positive, so my answer is positive. Cool. We did it. All right. Not too bad of a video, I guess. I thought it was going to be longer than that. That was pretty short. I have a lot to tell you about the review sheet. Would you please listen to me? Guys, please take my advice. I do know what I'm talking about, okay? Now, first of all, if you don't want to start the review sheet today, I think that's a poor decision. But I'm not, I'm not your parent. That's your decision. And a lot of your parents give you the leeway to make your own decisions with your math class. So that's up to you. But I would encourage you to start the review sheet today. If nothing else, this right here. This right here. What I'm circling covers what I taught you today. So if you want to practice today just what you learned today, then at least do that right there. Now, if you don't want to, it's up to you, okay? This is all your review sheet right here. This is your entire review sheet, so go ahead and write that down. But if you're going to do anything today, I would do this first line right here. Page 575, numbers 37 through 61 odd, okay? That's what I would do. Now, I've got some more stuff to tell you. You better listen, okay? What's EOO stand for? If you don't listen to me, you're going to do too many problems. That should get your attention. No student wants to do too many problems. 6 through 50, every other odd. That means you would do 6, skip the next even, which is 8, and then do 10. Then skip the next even, which is 12, and do the next even, which is 14. So basically, you're adding 4. You would do 6, then 10, then 14, then 18, then 22, then 26, and then 30, 34, 38, 42, 46, and 50, okay? It does come out right. If you'll start on 6, you'll end on 50, adding 4 every time. So that's what every other odd means, okay? And then don't miss this, please. The last line, notice, is evens only. So 2 through 32, just the evens. So 2, 4, 6, 8, 10, 12, 14, 16, 18, all the way to 32. So there's your review sheet. I'm looking at my notes now. I should have it written down somewhere. I think it's a grand total of 41 problems. That's about normal, guys. 41 problems. And now look what I'm doing. I'm changing something here, okay? These review sheets are fine, but what is happening is I'm sitting for 2.5 to 3 straight hours and making a video. Now I'm going to have all this posted tomorrow, but at least I can do half the review sheet and then take a break and do the other. I mean, not tomorrow. Yeah, tomorrow. I'll have this posted tomorrow, Friday, like I always do. But the review sheet will come in 2 parts. So the first part of the review sheet, I'm not sure where I'm going to stop at, probably midway through page 562 here. But you're going to watch Pre-Cal October 18th, review sheet part 1, and that'll be the first part of the review sheet. Again, I'm not sure where I'm going to start, but then where I'm going to stop at, but wherever I stop at, I will then pick up there and start in Pre-Cal October 18 review sheet part 2. So I'm breaking the review sheet up into 2 parts. Not for you, this is one review sheet for you, but for me, because it's very difficult to sit for 3 hours, as you can imagine, review sheet straight through, voice getting shot and without it being difficult to do. So I could do half the review sheet, post it, take a break, do the other half and post it. But they will both be posted at the same time on Friday, okay? So here's your review sheet. You know the drill by now. This is our 10th week. Congratulations, man. 10th week. And so you know how this works. You do not have to do the review sheet unless you want to. But if you do the whole thing, you will get 5 bonus points. It is on the honor system. And if you would lie about that, then I'm very disappointed. Hopefully you will not. This is due on Monday, so when you show up to class, you're ready to ask questions. And then you can ask a lot of questions and then take your test, or little questions and take your test, whatever. But this is the review sheet, and this will get you ready for the test, okay? Call me, email me if you have any questions. I hope you have a great rest of the day. Please work hard on your math.